Hey Tara, how's it going?
Okay, I guess. I'm working on a computer science project for one of my classes, and there's a bug in my program that I just can't find. I make my changes, compile it, check it with the debugger, and make more changes, and it's really a pain. It takes so long.
Wow, if you think that takes a long time, you should be glad you were born when you were. From what I hear, a long time ago, it used to be much harder to write programs.
Primitive? You mean back when there were no color displays and stuff like that?
Well, yeah, but that's really just the start of it. I've seen some pictures of old computers that are just amazing. I wish I had a way to show you. Wait, I know. I've been working on writing a program that controls a holodeck. We could use it to go back in the past and look at some of those old computers so I could show you what it was really like then. Do you want to give it a try?
A holodeck? You mean like on Star Trek? Sure, I'll try that.
Okay, well, we're going to have to get this thing set. Over here on this setting, we get to set the type of scene we want to view. We can see a sports arena, a computer lab. That's probably what we want, not a concert hall. So I'll set computer lab. And then this slider, unfortunately, I haven't had a chance to calibrate it yet, but this controls how far in the future or past we go. Let's go back about this far. I hope that's right. And then we'll get things started like this, and in 10 seconds, we'll be ready to see the scene. Hello?
Holy moly, how'd you get in here? You scared me.
Look, there's really no time for that right now. I'm Dave, and this is Tara, and we're just sort of interested in finding out what it is you're doing here.
Wow, what is this big piece of iron anyways? That looks ancient.
Actually, it's pretty new. It was just delivered a couple of months ago.
Wow, it's so big and loud. What kind of computer is it?
It's a PDP11
Wow, how much memory does it have?
The standard model comes with 16, but we decided to go with the extra money and get 32. I kind of doubt if we'll ever need that much, but we thought we might as well go for it just in case.
You mean this large computer only has 32 megabytes?
32 megabytes? No, this has 32 kilobytes. You know, 32,000 bytes? This computer can only have 64 kilobytes maximum. You must be confusing core memory with like disk drives or something, because some of DEC's new disk drives, like their RPO3, can hold 40 megabytes. Wow, I just can't imagine why we'd ever need that amount. But anyway, we couldn't afford the cost of an RPO3, so we don't even have any disk drives on this computer.
What OS does it have? Does it run DOS or Windows? What kind of ROM?
I'll be happy to show you here.
Look, that's really interesting, but there's really no time for that right now. We're really just interested in knowing if you can show us how to write programs for this machine.
Sure, no sweat. I just happen to have a machine language program I wrote the other day. So if you look at that, everything's in octal, you know, base 8, where a 5's a 101 and a 6 is a 110. And
yeah, and 011 means 3 and 010 means 2. I remember this.
Well, good. I'm glad you remember your octal. We'll be sure using it when we toggle. Why don't you have a seat while we do this? Okay. Now, what you'll notice on the front panel here is that the switches are kind of grouped in groups of 3 with the colors, and so each group of 3 switches represents one octal digit. A switch up is going to mean a 1, a switch down is going to mean a 0. So when we start here, actually I'll give this to you. So those are the addresses and then those are the contents. So the first thing we have to do is to put in the address of the first instruction, which is 1000. So we do 0, 0, 1, 0, 0, 0. And we then do a load address. Okay, so that tells us where we're going to start. And now we'll have to put in the contents. So why don't you read that to me, the 042.
Okay, 042510.
And then we hit this deposit switch, which puts that into memory. Okay, now just read me the next one.
046 114.
Okay, and put that in the switches and hit deposit.
Okay, 020 117.
Okay, okay.
0000.
Okay, program's in.
Wow, that's kind of fun.
Yeah, it is pretty neat. And once we have it loaded into memory, now what we can do, if you look at the sheet here, address 1020 is a starting address of the program, so we'll toggle in 1020, 001020, hit load address, halt up, and then when we hit the start button, it executes.
All this work for such a short program?
Yeah, you're right, that is kind of a pain. That's why DEC developed their paper tape software.
What's paper tape?
It's very similar to the punch cards that I'm sure you've used. I have some over there if you want to hand it to me. Yeah, thank you. So if you look at one of these tapes, well, here it is.
What are the holes for?
Ah, good question. The paper tape holds binary zeros and ones. A hole represents a 1, and each position that does not have a hole represents a 0. The paper tape reader uses light to sense the presence or absence of holes. There are 8 positions across a row of tape, therefore each row holds 1 byte of data. The entire tape then is a collection of bytes.
So this tape is kind of like a file.
Exactly.
How do you keep all these tapes straight? How do you know what each is named?
Ah, good question. We either get a label and type the name of the tape on it, or if I'm really kind of lazy, I can get out my marker and just kind of write the name of the tape on it. It's really kind of neat because we can use as many letters as we want and any kind of font that we want, and it's probably better than some of the current operating systems like that they write for the PDP11 that restricts you to have like 6-character names and a 3-character extension like prog.bas. In fact, I really can't imagine anybody's going to put up with that kind of naming scheme for much longer. There's got to be a better way to do it. Anyway, nice thing about these tapes is you can write however many characters you want to on it.
So when you want to get rid of a file, do you just put it in the trash?
You bet. And the good thing is that if we accidentally delete a file, I can recover it from the wastebasket. As long as the janitor hasn't emptied it, then it's kind of too far gone. But it is kind of a neat idea.
Just like Windows.
Right. I'm not quite sure what you mean by Windows. It does get pretty hot in the summer in here, and I guess some windows would be nice.
Right.
So what was that you were saying about loaders?
Ah, right. A loader is a program that takes bytes from paper tape and loads them into memory. Usually the paper tape contains a machine language program, and once it's loaded into memory, we can then execute the program. The problem is, how do we get the loader into memory to begin with?
I'm confused. Doesn't the computer already know how to program from the paper tape? I know the computer that I use boots the disk without doing anything special.
No, the only programs that the computer can execute are the ones that have been loaded somehow. And until we get the loader itself loaded into memory, we can't read any paper tapes into memory. As far as your computer, you must be using one of the new ones where the loading program is kind of already hardwired in.
You know, he's right, because in your computer, the loader's in the ROM, so you never really have to work with it directly.
What?
Well, could you just tell us how you get the loader into memory?
Good question. We toggle it. Here, look at the PDP11 programming card. It contains a copy of the bootstrap loader. All we have to do is toggle this program into memory, and we're in like Flynn.
So now that we have that done, what kind of programs do we have on paper tape?
Let's see, I have 3D tic-tac-toe, we have a Star Trek game.
Look, these programs and games and stuff sound interesting and all, but we really don't have time for that right now. Could you just show us how you write programs on this computer?
Okay, sorry about that. In order to edit a program, we need to use a program called the PDP11 editor. I have a copy right here. So what we're going to do is we're going to use the loader to now load the PDP11 editor. We did spend extra money for this high-speed paper tape reader. It can read 300 bytes per second. That's about 10 times faster than most terminals can print.
Wow, this is pretty neat. Look at how fast the tape is moving.
Okay, now that the editor is loaded and running, we can use it to enter an assembly language program. I just happen to have a good one right here. Would you like to type it in?
Sure. Where's the mouse?
Mice? We don't really have any mice around here except for Mickey over there, but I'm not quite sure how he's going to help us edit the program.
I see.
Now that we're done, we have to save it.
How can we save it? You said earlier that you don't have any disks on this computer.
Oh, paper tape, of course.
Cool.
Okay, now that we have our source program punched on paper tape, we can use the assembler to translate this into machine language.
Let me guess, the assembler's on another tape.
Absolutely. Here it is. Do you want to load it?
Sure.
Now I'll have the assembler translate our assembly language program into machine language. Keep in mind that this is a two-pass assembler.
I remember my org teacher talking about two-pass assemblers, but I don't quite remember what that means.
During the first pass, the assembler reads the source tape and simply constructs a symbol table. During the second pass, the assembler reads the source program again and generates the image in the listing. See, it's finished with the first pass and has just printed the symbol table. Now we'll put the source tape through again for the second pass.
So you actually have to put the source tape in twice. That's neat.
Yeah, and if you want to play with the assembler's mind, it's fun to put a different program in for the second pass. The assembler gets pretty confused.
Have you seen a psychiatrist lately? You seem to have a strange sense of fun.
What can I say? I'm a nerd. Anyway, you can tell that the computer has now finished producing the listing and punched a paper tape that contains a machine language version. All I'll have to do is label this. Any guesses how we can now execute this program?
By using the loader to load the tape, right?
Excellent. You're really getting the hang of this. Here, you want to try it?
Sure. Wow, this is really interesting.
Recapping how to write programs for the PDP11. Step 1. Use the loader to load the editor from paper tape. Step 2. Use the editor to edit the assembly language program. Step 3. Save the assembly language program onto paper tape. Step 4. Use the loader to load the assembler from paper tape. Step 5. Use the assembler to translate the assembly language program to a machine language program. Step 6. Use the loader to load the machine language program.
But what if it didn't work right? How do you fix it?
First you have to load the editor, then use the editor to load in your old source tape, use the editor to modify your program, use the editor to then punch a brand new tape, and then
load the assembler, feed the new source through twice, and finally feed the new image tape produced by the assembler. I think I have it. This process probably takes a while, doesn't it?
Well, once you get good at it, you can edit a program in about 5 minutes or so, which I think is actually pretty good.
And you thought 15 seconds was a long time for your C++ compiler to compile your program.
I didn't realize how easy I have it.
What do you mean, C++?
Oh, slip of the tongue. Look, it's getting really kind of late. We really need to go.
Hey, is that one of those new digital watches? I've always wanted to see one of those.
Do we have to go? I'd like to look inside the computer and see.
Look, I know you want to look inside the computer, but we really have to go. It's getting late. But hey, this has been really interesting. Thanks a lot for your time.
Oh, you're very welcome. Thanks so much for stopping by. I always kind of enjoy showing off my new computer here. Hey, before you leave, would you like some apples? I really love these Macintoshes.
Yeah, that sounds
Sure,
great.
thanks.
Thanks.
Hey, you're welcome. Well, back to coding.
Hey, out of curiosity, what is it you were working on anyway?
Oh, my boss is making me rewrite one of my programs. I originally wrote it to store 4-digit years, and he says it's a wasted amount of memory to store all 4 digits when I could just store 2, so I guess he's the boss. It must not be that important.
Little does he know.
Holodeck and program.
Wow, that was really cool. But you really better get back to work debugging your program now, I think.
Yeah, this looks like it's going to be easier than I thought. No switches to toggle, no paper tapes, no octal. It's going to be a piece of cake.